Hi everyone, welcome back to Fat Cat Maths. This video is part of my exam walkthrough edition. The best way to utilise the series is to pause the video and give the question a go. Then press play so that we can work through the answers together. If you haven't watched the Surds tutorial video, I'd recommend watching that first and I'll put the link below. Pause the video here and try this question on your own first. In this question we'll be adding two surds together, but it's really important to take note of where they have asked us to write the answer in the form k root 6 and where that k in front of the root 6 is a surd itself. As you know, in order to add two surds together, the same number has to be underneath the root. To do this, we have to split 48 into two of its factors and split 108 into two of its factors. I would really recommend before trying this question to write your square numbers somewhere on the page so that you can give yourself a reminder. So because the examiners have asked for the answer to be in the form something root 6, the best thing we can do is write down our different multiples of 6 and see if any of these can work as the factors of 48 or 108 when we split them up later. So just writing down the first few multiples of 6, we've got 6, 12, 18, 24, 36 and 48. We then have to look for a common factor of 48 and 108. There are two common factors of 48 and 108 that are also multiples of 6. 6 and 12. We want to use the highest common factor possible, so we're going to use 12. 48 can be split into the factors 4 and 12. And 108 can be split into the factors 9 and 12. Root 4 is technically not a surd anymore because we can solve it, so we're going to make that a 2. Root 9 is also technically not a surd anymore. We can solve it to make 3. So now we have 2 lots of root 12 and 3 lots of root 12. When we add these together, we can get 5 lots of root 12. We've now completed the first part of the question because we've added root 48 and root 108 together. But in order to get the second mark, we need to make sure that this answer is in the form k root 6, where k is a surd. We're going to do this by first of all splitting that 12 into a 6 and a 2. We can put the 2 and the 6 into separate roots, so we've got a 5 times root 2 times root 6. Just like in algebra, to simplify things we don't include the times sign, so we have a 5 root 2 root 6. Now we've got our answer in the format that the examiners have asked for. 5 root 2 is our k because it's in front of the root 6 and k is a surd. In question 2, we are being asked to simplify a set of brackets. Pause the video here and give it a go. Once again, I would suggest that you write your square numbers somewhere on the page. Before we expand the brackets, something that we should take note of is the form that they would like the answer in. The examiners want the answer in the form a plus b root 18, where both a and b are integers. Integers are just another word for whole numbers, so instead of a surd or a decimal, they are looking for a 1 or a 7. To expand a set of brackets, we do this just like with algebra. So we're going to start with 7 times 5, which is 35. Then we're going to times 7 by a negative 2 root 2, which would be a negative 14 root 2. Then we do 2 root 50 times 5, which is 10 root 50, and then a positive 2 root 50 times a negative 2 root 2. This would make a negative 4 root 100. The root 100 is a square number, so it can be solved because the square root of 100 is 10. That means that over on that right hand side we have a minus 4 times 10, which makes 40. So if we take our 35 from the front and our minus 40 on the end, and we simplify that, we have minus 5. We haven't changed anything in the middle yet, so we can keep that the same. We've simplified the numbers, so let's try and simplify the surds. In order to add those two surds together, we have to have the same number underneath the root. 50 can split into a 2 and a 25. We can see that that 25 is a square number, which means that we can solve it. So the square root of 25 is 5. We can times that 5 by the 10 in front, so now we have 50 root 2. A minus 14 root 2 and a 50 root 2 together will make 36 root 2. Then we still have the minus 5 from earlier on. We've now successfully expanded those brackets, but it's not in the format that the examiners want. In order to make the number underneath a root bigger, we have to square the number in front of it and add it into the root. But if we squared 36, that would make a really big number, and there's not really much point in doing that. So instead, we're first going to split that 36 into two numbers, and then square one of those numbers. 36 can be split into a 12 and a 3. If we write this out fully, we have 12 times 3 times root 2 minus 5. 3 is the same as root 9, because the square root of 9 would be 3, and 3 squared would be 9. So we can instead write that down as 12 root 9 root 2 minus 5. When we're timesing two sides together, we put them under the same roof, so it'll be 12 root 9 times 2, which will be 12 root 18 minus 5. When writing your finalised version of the surd, it's always better practice to put your number in front. So we end up with minus 5 plus 12 root 18. Now our answer is in the format that the examiners are asking for. A is minus 5 and B is positive 12. Integers just have to be whole numbers. It doesn't matter if they're negative or positive. So that's this question done. For question 3, we are given surds in the form of a fraction. So the first thing that should come to mind is I need to rationalise this. To rationalise a surd, we want to times the top and the bottom by a root 2. Now on the top we have root 3 times 2 and root 27 times 2. On the bottom we have root 2 times root 2. When simplified, on the top we now have root 6, add root 54, and on the bottom we just have a 2, because a root 2 times a root 2 is the number without the root. To add the root 6 and root 54 together, we need to have the same number underneath the root. So we're going to have to split that 54 into a 6 and its other factor pair. Root 9 can be solved because the square root of 9 is 3. So to simplify that, it will be 3 root 6. We can then add that root 6 and 3 root 6 together to make 4 root 6. They'd like the answer in the form root k, where k is an integer. That means that there shouldn't be anything before it and anything after it. It should just be a root and a number. The first thing we can do is divide the 4 root 6 by 2. This would be 2 root 6. Then, to get rid of the number in front of a surd, we have to square it and then times it by whatever is underneath the root. 2 is the same number as a root 4. If we times root 4 and root 6 together, we put them under the same root, so then it would be root 4 times 6, which is root 24. Therefore, k equals 24. For this question, we've got another fraction, so we would be expected to rationalise and then put it in the format 3 root 2. Once we've written out our square numbers, the first thing we want to do is times both the top and the bottom by root 8. Now on top we will have 12 root 8, and on the bottom we'll have an 8. We're going to want this in the format where the number underneath the surd is a 2, so we can change that now. At the moment we've got an 8, and we can split that into a 4 and a 2. The 4 can be solved to make 2, because the square root of 4 is 2, and we can then times that by the 12 to make 24. So we've now got 24 root 2 over 8. This has helped us out with the division as well, because we couldn't divide 12 by 8 in the earlier form of our question, but we can now divide 24 by 8, which is 3. So the overall answer will be 3 root 2, and that is the exact answer that the examiners want us to get to. This question seems a bit intimidating to begin with because it's not in the format that you would be expecting for a Surd-related question. Don't let it put you off though. You'll still be expected to do the exact same things as we've been doing in previous questions, but the beginning is just going to be slightly different. They've given us the area of a trapezium, so the first thing to do is write down what the equation is to find out the area of a trapezium. This equation will be half brackets a plus b, close brackets, times h. So we'll be adding the two parallel sides together, halving that, and then timesing it by the height. We've been given one of the parallel sides, but the second parallel side is an unknown. They've labelled it k. We've also been told that the height is root 3, so we actually only have one unknown, which means that we can put all of these into the equation and then make k the subject. In a trapezium, a and b are always the parallel sides. It doesn't matter which one is which, but in this case I'm going to label k as a and 4 as b. If I put these values into the trapezium equation, I've got the following: half brackets k plus 4, close brackets, times root 3. We can then say that all of this equals the area, which is 5 root 6. Because in this question they want us to calculate the value of k, we need to try and make k the subject of this equation. That means having it on its own and everything else on the other side. The first thing I can do is get rid of that half by timesing the other side by a 2. So now I have brackets k plus 4, close brackets, times root 3 equals 10 root 6. I can then simplify this further by moving the root 3 onto the other side. Remember that we can move anything in an equation to the other side of the equals as long as we do the opposite to what it was doing before. So instead of timesing the left side by a root 3, we're going to divide the right hand side by a root 3. We can then move that 4 onto the right hand side, and remember we do the opposite to what it was doing before. So instead of adding a 4 on the left hand side, we're going to take away the 4 on the right hand side. Now that we've made k the subject of our equation, we just need to check that it's in the right format for the examiners. They've asked for the format a root b minus c, in which a, b and c are all positive integers. You might be looking at the minus 4 in our answer and thinking that we haven't got all positive integers, but because the format that they want is a root b minus c, our c is a positive 4, just with a minus in front of it. Great, so that is the end of the video. Thank you for taking the time to listen. I hope it helped. Good luck with the rest of your revision, and please hit that subscribe button. See you next week.